Okay, 31.4 is binomial expansion. That means we have a binomial raised to some exponent and we're trying to expand it out. So let's start with the first one, x plus y to the 0. We know anything to the 0 is equal to 1. X plus y to the first power, anything to the first power is just equal to itself. So x plus y. X plus y quantity squared, if we were to multiply x plus y times x plus y, distributing that gives us x squared plus xy plus xy plus y squared. So if we combine like terms here, this is x squared plus 2xy plus y squared. All right, now if we cube it, that means we could take this answer and then multiply it by one more of the x plus y. So let's take this answer right here and multiply it by another x plus y. So distributing this, we get x cubed plus x squared y. Distributing this, we get plus 2x squared y plus 2xy squared. And distributing the last term here, plus xy squared plus y cubed. Let's try to combine like terms now. So x cubed is by itself. X squared y can combine with 2x squared y. So that's plus 3x squared y. 2xy squared can combine with 1xy squared, which is positive 3xy squared. And the y cubed is by itself. So let's write that in here. So x cubed plus 3x squared y plus 3xy squared plus y cubed. Now one thing we also are going to do here in these parentheses, it says fill in the coefficient of each term in the parentheses. So we're going to take the coefficients only and fill them in here. And we're going to start trying to look for a pattern so that we don't have to do this tedious process of multiplying out. So here the coefficients are both 1s. Here the coefficients are 1, 2, and 1. Here we have 1, 3, 3, and 1. Now let's see if we can start looking for some patterns here. X plus y to the 5th power is already filled in for you. And I'm going to go ahead and fill in x plus y to the 4th instead of multiplying it all out. All right, so the coefficients here will be 1, 4, 6, 4, and 1. So let's look at these questions so that we can go back and see if we see any patterns here. First question is, what is happening to the x terms in the expansion? If we look at the x terms here, notice that the exponent is decreasing on each term. And it starts from whatever the original exponent was in the problem. So here this starts with a 5, here this starts with a 4, this starts with a 3. So from the original exponent, and it goes all the way down to here there is no x. So that means the exponent, this was a 1, and here the exponent is a 0 because the x disappears. If we look at the y terms in each expansion, so looking at these, here there is no y, that means the exponent was 0. Here it's 1, 2, 3, 4, 5. Here it's 1, 2, 3, 4. So the exponent for the y term is increasing. And it's starting from 0, because you don't see a y on any of these, and it's increasing by 1 each time, all the way up to whatever the original exponent was. Here it goes up to 4 because the original exponent was a 4. And the last question here asks, the exponents in each term add up to, so if we look at the exponents in each of these terms, here the exponents add up to 4, here the exponents add up to 4. If we look down here, 5, 4 plus 1 is 5, 3 plus 2 is 5. So notice they're all going to add up to the same number, which is equivalent to whatever the original exponent was. So they add up to the exponent in the original problem. So let's look at one more thing, which is this triangular pattern of numbers. If we try to find a pattern here so that we can fill in the coefficients for any exponent, this triangle could go on forever. We have a 1, 1, and 1, and these two numbers add up to this number. These two numbers add up to this number. These two add up to this. Notice the edges are all ones, and everything else is the sum of the two numbers above it. 6 is the sum of 3 and 3. And looking anywhere here, 10 is the sum of 6 and 4. 5 is the sum of 1 and 4, and so on. So we can fill this triangle in indefinitely as many rows as we want. So this is a 1. Here we get 6, 15, 20, 15, 5, and 1. Here, if we add these numbers up, we get a 7. The edges are both 1s. 15 plus 6 is 21. 15 plus 20 is 35. This is 35. 15 plus 5 is 20. 5 plus 1 is... Oh, this should be... I made a mistake here. This should be a 6, which means 6 plus 1 is 7.